Welcome to my Kcse revision channel, Jamaita, Pilgrims Boys High School. Kindly subscribe, click the notification bell such that you get notified once I upload a new video. Today we are looking at paper 2 question, mostly tested question, that is relevant is compound, and today we are looking the preparation of hydrogen sulphide. So I have a diagram here which is used for the preparation of hydrogen sulphide, where we have substance W, then we have substance C, or you talk of solid V, we can have water, then we talk of substance X, and of course we have the methods of the gas collection. So in the first flask, you are supposed to understand here is where we have the reagents which is used for the preparation of the gas. And of course, you study the purpose of water in this experiment. In where we have this YouTube, is the YouTube normally contains the drying agents. And in this case, we have three main commonly drying agents. That is concentrated sulfuric acid, the calcium oxide, and of course we have anhydrous calcium chloride. So we are going to see the suitable drying agent that can be used to dry the hydrogen sulfide gas. And then here you can see the methods of the gas collection. So we have various methods of the gas collection. We have gases collected by the upward delivery method, which is the downward displacement of air. You can also talk of the downward delivery method, which is the upward displacement of air. And then you can also, we have gases which can be collected over water, over cold water, over warm water. So here we have normally the methods of the gas collection and the property that makes the gas to be collected by the given method. So we are supposed to name substance W, solid X, and the solid Phi. If we start with the substance W and Phi, substance W and Phi are normally the reagents used for the preparation of this hydrogen sulfide gas. And what are the commonly reagents used? We talk of the dilute hydrochloric acid or the dilute sulfuric acid. Such one you can have this substance W as either the dilute hydrochloric acid or dilute sulfuric acid in this case. When you talk of substance V or solid V, this one must be a soluble sulfide which forms a soluble salt with the acid. So it must be, we must have the commonly used sulfide here is iron 2 sulfide because it normally forms a soluble salt with the acid. Then we have now that this substance X is a reagent used for is a reagent used to dry the gas. So W is a dilute hydrochloric acid or sulfuric acid. X is anhydrous calcium chloride. The best or the most suitable drying agent for hydrogen sulfide gas. And then this Phi is this substance Phi or solid Phi is normally hydrogen sulfide. It is the commonly used sulfide, iron 2 sulfide. It is the commonly used sulfide because it normally forms a soluble salt with the acid. Then now we have onto this substance X, maybe will be asked to give a reason why the concentrated sulfuric acid or calcium oxide cannot be used to dry the gas. The concentrated sulfuric acid cannot be used to dry the gas, as you know that the hydrogen sulfide gas is a strong reducing agent. Therefore, what will happen here, if you dry using the concentrated sulfuric acid, it will normally oxidize to sulfur. If you will be asked also to give a reason why the calcium oxide, which is also another common reagent for drying the gases, that it cannot be used to dry this gas. Calcium oxide it is a base, and hydrogen sulfide it is an acidic, so they can normally react because you know a reaction because you know an acid and a base can just react, and that is the reason is why either the concentrated sulfuric acid or the calcium oxide cannot be used to dry the gas. Write a question for the preparation of hydrogen sulfide. We normally talk of the iron 2 sulfide reacting with the dilute hydrochloric acid. or sulfuric acid. Then we have a soluble salt of iron 2 chloride, and then you collect the hydrogen sulfide gas. What property enables it to be collected by the method shown on the diagram? So this gas, the method shown on the diagram, the method is just the downward delivery or the upward displacement of air. And what is the property that makes this gas to be collected by this method? It is because it is denser than air. What you need to understand, if you have the oxygen, an oxygen molecule, we have two molecules of oxygen, so we can have this is 2, and then we have times 16, we can have this one as 32. This is air in this case. When you talk of the hydrogen sulfide, we have two molecules of hydrogen, then we have one molecule of sulfur, which is giving us in this case 32, and if you add that one, you will get 34. So what you need to understand that the hydrogen sulfide is more denser. This one it is denser than the air. It is denser than oxygen. So because the density of hydrogen sulfide is higher than the density of oxygen, that is why the gas is collected by this method shown here, which is the downward delivery method or the upward displacement of air. If the gas can be collected over water, then it must be collected over warm water because the hydrogen sulfide is fairly soluble in cold water. So it must be collected over warm water. If the gas is not required dry, it can be collected. If it is not required dry, it can be collected over warm water because it is fairly soluble in cold water. What is the purpose of water in the second flask? So normally the purpose of water in this second flask is just to remove the traces of hydrochloric acid or to remove the traces of HCl. What precaution should be taken when preparing the gas? So normally you understand that the hydrogen sulfide is a very poisonous gas. So the precaution here, the gas must be prepared in a film chamber or must be prepared in open because the gas is poisonous. Hydrogen sulfide gas is normally poisonous. State 2 physical properties. State 2 physical properties of hydrogen sulfide gas. You just say that the gas is denser than air, that is when it's collected by the downward delivery or the upward displacement of air. It is colorless. It has also what we call the characteristics smell, rotten smell. So we have that characteristic of a rotten smell. Describe a test for the hydrogen sulfide. The hydrogen sulfide gas normally tested using either the lead-2 acetate or you can use the lead-2 nitrate. What happens here, when the gas is coupled through lead-2 nitrate or lead-2 acetate, there is a formation of a black precipitate. And the black precipitate normally confirms that the gas produced is normally hydrogen sulfide. State the observation that could be made. State the observation that could be made when a hydrogen sulfide is coupled through the acidified potassium dichromate. So we have this is acidified potassium dichromate. What is the observation made when the gas, hydrogen sulfide gas, is normally coupled through the acidified potassium dichromate, which is orange in this case. The acidified potassium dichromate it normally changes from orange to green. That is normally the observation that you can make from here. And this question is normally testing the reducing property of hydrogen sulfide. The hydrogen sulfide is normally a strong reducing agent. And what happens here, there are several examples of this reducing agent. Apart from using the acidified potassium dichromate, you can also use the acidified potassium permanganate 7, which is purple, whereby the purple acidified potassium permanganate 7 can be reduced to manganese 2, which in this case colorless. If you use the bromine water, the red brown bromine water will be normally reduced by the hydrogen sulfide gas to hydrogen bromide. Hydrogen bromide in this case it is colorless. You can also have another example of as a reducing properties of this hydrogen sulfide. It can reduce the hydrogen peroxide to a colorless liquid. So if you have a hydrogen peroxide with this gas, hydrogen peroxide it can normally reduce it can be reduced to water. You can also talk of the nitric acid in this case, and the nitric acid can also be reduced to a brown gas. And in all cases where the hydrogen sulphide gas is acting as a reducing agent, there is always a formation of a yellow precipitate of saliva. Now, why it is not advisable to dispose hydrogen sulphide gas by panning? What you need to understand that hydrogen sulphide burns in air with the formation of a harmful gas, and this harmful gas is a sulfur oxide, which in this case forms an acid rain. So it is because of you cannot dispose using the panning because it normally forms a harmful sulfur oxide gas, which forms the acid rain. Stage 1 use of hydrogen sulphide. So one use of hydrogen sulphide is just to say that the hydrogen sulphide is normally used in preparation of metallic sulphides. Alongside here, I have another